My name is Anoop Rajendra. I am, as it says, the Director of Enterprise Software Development. That's a very fancy way of saying I meet with clients and then in a post sale and then figure out what they want and then try to charge them some more money. So I have been involved in one way or another with the Stacki project for the last 10 years. So Stacki as a project started out in its initial form as a project called ROCKS, came out of the University of California at San Diego. So I was part of that, I joined that team in 2005. About 6 years after I joined, there were 4 people in the group and 3 of us decided, or two of the people decided that it would be a good idea to make some money off of it because we saw a lot of value in it. So I started the company called StackIQ. I joined a few months after that and I've been working with them pretty much ever since. So as I mentioned, one way or another I've had a lot of experience with the software and I've been in multiple roles in the company. But just that's enough about me, so let's do Stacki. So what is Stacki? The marketing blurb is Stacki is a very fast, ultra reliable Linux server provisioning tool at scale with 0 prerequisites for taking systems from bare metal to a ping and a prompt. I'm reading that verbatim because otherwise my marketing guys will shout at me. So, but I wanted to kind of qualify what every one of these things actually means. So when we talk about Linux, we're actually talking about specifically in this instance Red Hat and Red Hat based systems. So CentOS, Oracle Enterprise, we have scientific Linux support as well. We have Ubuntu on our roadmap. There is no product yet, but we do have Ubuntu support on our roadmap as well. What does provisioning mean? Provisioning basically means you get servers from Dell, HP, IBM, Cisco, what have you, get them on the loading dock, pull them out of the box, put it in the rack, connect the network, connect the power. You have a blank box, you have a blank slate to put stuff on. If you want to make that useful, you have to basically install everything on it, right? You have to install the OS, you have to configure networking, you have to configure the disks. All that stuff is basically what provisioning means. And that's what we do. It's a full stack provisioning tool. At scale, when we talk about scale, we're not talking about tens of servers or hundreds of servers, we're talking about thousands of servers. Salesforce recently installed Stacki on 4,000 nodes. PayPal installed it on they also installed it on multiple locations of about 1,200 to 1,400 nodes each. So we have, those are like the 2 big clients. We have other clients who use the enterprise version, which is basically we have American Express, Verizon, and those kinds of people who actually use this at scale. With 0 prerequisites basically means you don't need to have anything installed on the system before you actually start anything. So you go from the ground up, from bare metal and up to a ping and a prompt, which basically means you have SSH running, you have networking up, you can actually log into the system and start running utilities. So it gets you up to a ping and a prompt. The other terminology we used to use before was pallet to prompt. When we said pallet, basically means the pallet shows up on your loading dock, pallet to prompt. So that's what Stacki actually does. So how do we actually do this? By the way, this is not an easy problem. I mean, if you've ever installed Linux, you know that it actually takes you 20 to 30 minutes to install one system. Now, if you want to replicate it, you use cloning clones, Clonezilla, ghost images, and things like that to actually do copies. And then you have a bunch of images that you now have to go individually into and modify. That's one option. Or you could just basically go install and configure every single node as is, and then try and configure them. So this is not an easy problem. So, and scaling this is definitely not an easy problem. So how do we solve this? We solve this by basically taking control of the entire stack at the bottom layer. Now, when we talked about Stacki in the past, StackIQ, the company in the past, we used to actually handle all those different layers. We used to handle the application layer, we used to handle the DevOps configuration layer, we used to handle the OS provisioning hardware configuration layer as well. What we found out was, as we went from client to client, most people had their own tools to do DevOps and application deployment. So we would go into a company and they would say, we already have Puppet and we like how we use Puppet. We like that we use Puppet to install Cloudera, for example. And we don't want to move away from that because we have all this expert knowledge that we've built into the system. What we had was basically a full stack automation tool. So we decided somewhere along the way that it was, so the bottom layer was where most people had the pain. People would basically look at the bottom layer and go, this is super hard. We have a separate team dedicated of 5 or 10 people dedicated just to do the bottom layer, and that takes them weeks to do a small setup. And what we decided was we had that tool which could actually do the whole thing in a couple of hours as opposed to a couple of weeks or a couple of months. So we decided to take basically the whole layer at the bottom and then automate all of it. So what we automate is the OS installation. We automate disk configuration, and when I say disk configuration, we're talking about disk array controllers. Who here has dealt with the HP controllers or LSI Mega RAID controllers? Okay, so the knowledge that I got from a friend of mine who did this without using Stacki was to get one controller, LSI Mega RAID controller, one of them, configured the way he wanted. It took him 80 keystrokes. And this is just navigating through the BIOS, right? Navigating through the legacy BIOS. So we decided we were going to completely automate that. And we did. So we have support for LSI Mega RAID controllers and HP SS controllers. So if you've dealt with that, you know the pain of actually using the BIOS setup to actually configure those systems. So we decided to automate all that. The other part of the disk controller we automated was the partitioning. So we realized every application has its own needs for disk usage. Hadoop uses disks in one way, Cassandra uses it in a different way, OpenStack requires a completely different way of doing things. MapR, in fact, uses a different way of doing things because it requires you to have raw disks. So we have all these different configurations that we needed to support, and we needed to automate somehow. So we did that. And we did that by basically studying how people use their systems and their infrastructure and then automating all that part. Then we take care of the networks. When we talk about networks, we are talking about the entire stack again. We can automate InfiniBand, we can automate the networking stack, the standard 10G, 1G Ethernet to 10G Ethernet. All that basically is automated. And when I say automated, it means that from the get-go, when you install the system, you have networking up with the right gateways, the right IP addresses, the right netmask, all that fully set up. The machine comes up and you have a usable network stack already set in place. And then finally the services. Now, if you've ever dealt with application clusters, by the way, I keep using the word clusters because those are our roots. We came from the university side, so we were actually building high performance clusters before they were cool. And when people actually started building Hadoop systems and Cassandra systems, they rewrote a lot of that logic, or they reused a lot of that logic without realizing that a lot of work was already done in the high performance computing space. So we basically said we have all this expertise in the high performance computing space, and we can see that the architecture of one actually maps very nicely with the architecture of the other. So we can actually translate it directly almost. So that's why I keep using the word clusters. So when you actually when you deploy clusters, you actually have to have a bunch of services running that will help you deploy. You need to have naming right. You need to have the networking correct so that you can actually DHCP, get the Pixie stack right, get the TFTP installation going correctly. All those things have to basically be set up correctly for it to function. So we decided to automate that part as well. And that was basically, so that was the boundary where we drew the line and said, if we automate all these things, everything above it we can treat as an application. Even your DevOps tools can actually be treated as application layer tools for Stacki. Oh. So this is what a typical data center architecture looks like. I will apologize in advance because this is not the only one. I know I'm going to get into trouble when I say this is one of them. We support multiple networks, but this is at the core the simplest architecture when it comes to deploying a cluster. So you have one network, you have the front end, which is what we call a management node, connected on that network, and you have all these back-end machines, worker machines, whatever the terminology you use, connected to onto the same network. You can have multiple networks on this side. You can have multiple subnets on this side, all supported through the same front end. It's just not represented on this slide, but all those different kinds of architectures supported. But we'll talk about the simple ones. This is basically, at the core of it, a very simple network diagram for how a cluster looks. So how do you deploy that? This is basically a screenshotted slide, which is telling you download the Stacki ISO from Stacki.com, put it in the machine, start booting it. This is the first screen you see. Choose install the front end via the DVD. Front end is what we call the management node, as I said. The first thing you see is this screen, which is a time zone screen. Select time zone that you're in. Obviously, we are in San Diego, so I'm going to choose the Los Angeles time zone. Enter your networking information, which basically tells you, you're supposed to supply the host name, the device you want to configure, the IP address of the device, the net mask, the gateway, and the DNS servers. Very standard stuff. Any machine you want to configure, you have to do all this. Supply the root password. Partitioning, you can choose automated or manual. So manual partitioning actually takes you, because I mentioned earlier that we are Red Hat based, and the reason we are Red Hat based is because we take the Red Hat installer and modify it, and we basically make the Red Hat installer, we make ourselves sort of hack into the Red Hat installer to do a lot of the work. So when we choose manual partitioning, what happens is it drops you into the Red Hat partitioning screens. So you basically go through that screen and you configure your partitioning exactly the way you would on any other Red Hat machine. If you choose automated, which is what we recommend for most people because they don't really need to do manual unless they have very specific needs. Again, this is only for the front end, so we're not talking about all the back end nodes and things like that. So only for the front end. You choose automated, it makes certain sensible decisions. Things like 16 gigabytes of root, 16 gigabytes of var, takes up the rest of the space in something called an export partition, where you actually can store a lot of your other sorts of data, a lot of Stacki data itself, Stacki data itself is stored in it, and things like that. So you choose automated partitioning, and then finally you come to the software selection screen. I should take an aside here and explain what a palette is. I know it says palette selection. We have an entity inside of Stacki called palettes. Now what these palettes are, again, we stopped, by the way, I don't know if you remember, but earlier I said palette to prompt. We stopped using the word palettes, we stopped using that line because it was confusing people with this palette. So what we mean when we say palette is it's basically this entity inside of Stacki that is a combination of binary data and configuration data. It is actually that simple. So when we design palettes, these are things that, palettes are also distributed in an ISO format. So it comes on a CD. So what a palette has in it is basically RPM data, the Red Hat package management data, and then configuration on how to configure services around those packages. So, so what we supply when you download the original Stacki ISO is you get the Stacki palette, which is all the secret sauce that we put together, and you get the OS palette, which is basically a stripped down version of CentOS. So we take the CentOS ISO, remove a lot of things that that would normally not be necessary for a cluster to be stood up, and then we take the remaining bits and put it on this ISO as well. So we have a stripped down version of CentOS and the Stacki palette, which is basically our secret sauce. I forgot to mention earlier, this talk obviously is for you guys, so if you have any questions, please feel free to stop and ask me questions along the way. So I should have mentioned that first.
So Stacki right now, the Stacki ISO only is, like you said, a stripped down version of CentOS.
Yes.
And there's no other.
So Stacki, again, it has our bits, the Stacki palette, which is the stuff that the software that we write, plus the stripped down version of CentOS. Yeah.
Right. Is there any other Linux version of OS? Other distro? Yeah,
so in the distro that we provide, no, but every one of those things can actually be added on after the fact. So once you get the front end up and running with this bare system, you can actually add a full CentOS distribution or a full Red Hat distribution or a full Oracle Linux distribution onto the system. And what that does is it basically what each of these represents is basically, think of each of these things as a repository, as a Yum repository. Basically, that's exactly what it is. And so when you have the front end up and running, you can add new Yum repository. Just like you add new Yum repositories, you can add new palettes. So you can take the Red Hat ISO that you download from the Red Hat website and add it onto the system. And I can actually show you how to do that in a little bit when we kind of go through the demo. So this is basically what this is where you make your software selection screen. You choose both Stacki and OS. You have to have both. Otherwise you're just going to get, well, almost nothing. So you have to have both. Click next. You get a summary screen. This basically tells you all the things that you've just entered. Just in case you think you made a mistake, you can go back and correct it. And then you say install and you're on your way. The first installation screen is it downloads, because you're doing it from an ISO, it downloads all these palettes from the ISO onto the disk itself. So it finishes partitioning first and then downloads all the bits onto the disk and then installs from disk directly. And then you're off to the races. You basically have this process takes about 20 minutes to run, and you have a full-fledged front end up and running at the end of it. When the front end is finished, you have it basically has all these things already set up and installed.
Right, went to the wrong door.
So you have the DHCP service running, you have TFTP configured correctly, named is configured, which is basically going to be, again, a hard problem to deal with. So, and we've actually made that optional. So one of the other things that we found out was in a lot of companies, people actually had their own name servers outside. We used to manage the name server for the cluster itself, but people said, no, we want to manage the name service as an external entity. So we said, we will actually separate that part out. So, no.
Thanks.
Yeah, that's all for you.
I'm about as hungry.
Yeah.
It's not Valentine's Day.
So we have all those services already up and running, and we also have services that help you access the backend nodes, which is key management. There is a parallel execution shell which actually sits on top of SSH and tries to help connect to your entire cluster. So actually at this point I'll pause briefly and sort of go to an actual installed front end. So this is the front end I installed yesterday. So it's been up for about an hour now. Let's see. I don't know if you actually store the. Okay, I guess we don't store the information anymore. But this was basically installed yesterday, and I have a full front end up and running right now. So I'll walk you through what we have on the front end itself. So once you have the front end up and running, the Stacki bits that we installed basically comprises of a Python library. So most of the code is written in Python. So it comprises of a Python library. It comprises of a command line interface to deal with the entire system. So the command line interface is basically simply named stack. So if you do that, you get a command prompt. you can double tap on it to get all the commands that we support, or you could also do stack help. That gives you a list of every single command that we actually support. So if you've used there's a particular utility called track, which has a really nice command line, and that was the inspiration for a command line like this. So we have a huge list of commands. In fact, we've got, let's see, how many commands? 205 commands that you can actually run. So you can configure all sorts of crazy things. But there's a very specific way you can actually control commands. And there's a very specific syntax to this, which is stack is the command itself, and then it is followed by a verb. So you can do add, set, remove, sync, load, unload, and a couple of others. List, of course, list and report. And then you have the actual object that you want to run it on. And so that would be something like the host name itself, the host itself, or how do you, or the network interfaces on the host. So, for example, if I want to know what machines my front end knows about, I do stack list host. It shows me just one machine, which is the front end itself, and basically it's assigned a certain rack, rank, CPU. By the way, I'm running all this through VirtualBox, so that's why this is going to be kind of a smallish system. It tells you what the distribution is. So the part that says box, that actually means what kind of a distribution it is. In this case, we've called it a default distribution. I'll kind of cover what a box means in a short while. It also tells you what the run action and the install actions are, which means if I put it in run mode, what should it do on next reboot? If I were to put it in install mode, what should it do on the next install, not on the next reboot? That's basically what those two things mean. Again, like I said, I'll briefly cover those things as well. But basically what this is telling you right now is you've got one machine, which is the front end itself, is the management node itself, and it's got one interface, one network interface, which is ETH0. Default basically says that this is the default network. It's sitting on the private network, which is what my VirtualBox setup is. The MAC address of the machine, the IP address that I've defined, the name for that interface itself. So now, having a front end up and running is obviously great, but it's not going to be doing any work. So if you actually want to make your cluster useful, you should actually have all the backend machines installed. So how do you go about that? There are two ways we can actually achieve this. One is what we call host discovery. Host discovery is basically where you have a bunch of machines in your network. And you know that all the machines in the network are your machines. So when they DHCP out or when they request for new addresses, nobody else is going to come and respond to them. So you have full control over your network. What you can then do is you can actually put your front end in what is known as discovery mode. When you put the front end in discovery mode, what happens is there's a daemon on the front end that actually sits and listens. And it listens to like the DHCP network trying to see who's requesting addresses. And any new request that comes in, basically, it's basically captured, put in the database. You get a new entry in the stack list host command, and it adds it to the database. It basically configures the networking for it, the IP address for it, and then sends it back its information. So we calculate all those parameters based on a certain set of rules. What we consider expert rules, mainly because we talked to a bunch of people, this is how they thought it made sense, so we said, okay, we're going to try and automate that and make that the standard. So to put this in discovery mode, you would run a command called insert ethers. It would actually tell you what appliances, what kind of an appliance you want to install. Right now I only have one type of appliance, so any new machine comes on the network and requests an image, it's going to be assigned the backend appliance type, because that's the only one that we support out of the box. You can create all sorts of appliances, post installation, but out of the box is the only one we support. So you come up with the screen, you boot up a machine in the background, it requests DHCP, and you're going to see an entry here. I don't want to go through that right now, mainly because I am a little skeptical about my network, so about the VirtualBox networking itself. So I will show you, I will demo the other one, the other method. So as I mentioned, there are two methods of adding hosts into your cluster. One is discovery. The second one, which is what we have found to be tremendously useful, is called the host configuration spreadsheet method. So we can go back to the PowerPoint for this. This is what a host configuration spreadsheet looks like. Now, if you've noticed that this maps almost exactly to what we saw in the stack list host interface command output. You have the host name, you have the appliance type, you have the rack and rank. By the way, those are all legacy things. I know people use racks and ranks in very different ways now. Rank simply means where in the rack itself that node is positioned, just to kind of give you a physical, just to give you kind of a physical location for it. These are not obviously automatically discovered. You have to actually, as the admin, know where each of them has to go. So those are all pre-filled. The IP addresses that you want to assign to those nodes, and the MAC addresses for those nodes, the interface that they sit on, and the network that they're supposed to belong to. Now, the reason, so for the longest time, we basically had just the discovery method of doing things. So that actually put us in this box, which was very, very nice for some people, but really difficult for a lot of other people. So some people who got their machines up, they had no idea what their MAC addresses were. They would turn on discovery mode, turn on all their machines, walk away, come back 20 minutes later, their whole cluster is fully installed, fully configured. They didn't have to touch anything. That does not work in corporate. The problem with corporate networks is everything is super regulated. So you have to know exactly what the MAC addresses are, exactly what the IP addresses assignments ought to be, what the names they can get are, because a lot of that, when you go through discovery, is automatically discovered, right, or rather automatically assigned. But in a corporate data center, that will not fly. Right. So what we decided was we have to have a way of saying this is how you do the assignments. So initially you can use the command line to do assignments, by the way. So if we go back to the command line, you could say stack add host, and you can actually say what the host names are. By the way, if you don't actually provide anything, it just gives you the error message and tells you what the options are. So you add the host. Again, I'll cover what a box is later. Basically, as I said, it's just a distribution or a repo. How many CPUs it has, what membership it is, either front end or back end, the appliance type, what rack and what rank. And once you add the host, you would say add host interface, and then you would add the interface parameters. So if you have a very tightly controlled network, this would have been how you would do it earlier. We would talk to multiple people, multiple clients, and they would say, this is great, but it would be nice to automate this for many systems, because we literally have to hire a guy just to type all these commands in. And the way they would do this is they have a spreadsheet. They would put a spreadsheet up on one side, and they'd have all these entries which said this is the host name, this is the MAC address, and this is the IP address. And a guy would look at that and type it in. And we'd see that being done multiple times in multiple locations. And we decided that because everybody likes using spreadsheets, why don't we make, instead of making the spreadsheets represent the truth, represent how they want the cluster to look, how they want the data center to look, why don't we make the spreadsheet the truth? Which is, you just take the spreadsheet directly into the system, you import it directly into the system, that way nobody makes an error typing. And if you've made an error in the spreadsheet, change the spreadsheet and import it again, and it'll just overwrite the bad information that was there beforehand, right? So we decided that is a better way of actually automating this infrastructure. So we actually wrote a command for that.
Could I ask a question?
Of course.
As in your dealings with other folks, have they mentioned vendor spreadsheets? For example, I work for an organization that we order a ton of gear from all the vendors.
Right.
They give it to us in a digital file.
Right.
And therefore, that's what we often get. And occasionally, you might have a mistake on it. It's
correct.
Never been talked about.
Yes, actually, because I think the best example is probably Cisco. We haven't dealt specifically with mistakes as such, but yes, I've heard of vendor-specific spreadsheets, which is you get a bunch of gear from Cisco or HP for that matter, and they give you a spreadsheet which has all this information in it. But it's very simple. It's just like MAC addresses and nothing more, right? So, and it tells you like, these are the MAC addresses and this is the serial number. So the guy who actually racks all the gear in and makes all the network connections and the power connections, they have an idea of what MAC addresses sits at what rank or what.
The vendor gives you a layout of all the ports.
Exactly.
MAC addresses.
Right. Exactly. So once you have that information, you still are, as the admin, as the architect of that cluster, you're still going to be required to kind of coordinate with your networking teams to sort of assign it IP addresses and things like that. So that part you still have to go through anyway, right?
We have.
Yeah. So you have to go through that. So when you go through that process, if you were to actually include this information in it, in a certain format, you would end up with a spreadsheet that's basically fully compatible with Stacki. So the things that you're actually supposed to enter are like that. So you have the host name, the interface host name, which means if you have multiple network interfaces, you basically can assign a different name for each of those interfaces. You assign whether an interface is the default interface for the machine or not. Typically what default means in this case is it just controls routing. So is this the default route that you define on the machine? Again, rack and rank, IP address assignment, the MAC address of the machine which you would get from the vendor, as you mentioned, the interface itself and the network that it's supposed to belong to.
So,
yes,
I've
go
got a
ahead.
question on this sheet. You said that you can assign an interface host name for a second interface. So, what would another interface on one of these machines look like? If you had a second interface on 0, 1?
It would just go Ethernet 1, 2, 3.
Remove that. You say, let's say 10.1.3.253, and this one would be, let's say 21, ETH1,
Right.
management. That's what it would look like.
Okay.
That's it.
So instead of false, you just leave the default blank.
Yeah, you would leave the default
True.
blank.
Okay.
Yeah, you could set it as false. Either is okay, but
Okay.
typically that's more typing, so you don't leave it.
Sure.
Yeah. So you can leave it as false. And I mean, this is such a simple spreadsheet. That's why it looks the way it looks. But actually, I'm going to show you another spreadsheet that we use internally. So
basically, if we get a spreadsheet, like you were saying, from a vendor,
Yeah.
we wanted to look at this format,
Mhm.
this type, these columns.
exactly with these columns, and
Still have to populate it with IP.
Yeah, you have to
Right,
still
right,
populate it with IP addresses
Sure.
and some amount of actual, commentary,
Other
right?
details.
Exactly. So, while you're doing that, if you get all these things right,
We call it a wiring layout that you have to overlay to the
Mhm.
sheet. All that work has to get done before you
Right.
get here.
right, yeah.
So is that options column basically an ETH tool options? If you define ETH tool options in your
I
if
believe
config
that
file?
is correct, but it is also context specific. So if you have bonding, you can actually specify bonding options as well. So if it's a bonded interface, you can specify bonding options. Bridge interfaces can do that.
Right.
I don't think VLAN options are there, but I don't know. I'm not
Well,
very
you've
sure.
Got another column.
No, yeah,
right?
no, we have another column, but that's a VLAN ID column. So if a particular network has to go on a certain VLAN, you
Okay.
create a,
So
yeah, it's a tag VLAN.
Tagging.
Yeah, it's for VLAN tagging, exactly. So you can actually specify all that information there. So I've actually imported the spreadsheet onto my front end, so I can show that to you. So if I were to do stackdemo.csv, there we go. It looks basically exactly what we just did. Lacking the ETH1
Right.
of back in 00 because I don't actually have that. So all I do is do stack load host file equals Stacki demo. Please work. There we go. I'm always nervous when I run this. Yeah. So what this did was basically read the CSV file and put it in the database. So now if I do stack list host, I have all the other machines there. Stack list host interface, I have all those machines there as well. I suddenly realized that I've screwed up the MAC address for backend 01. I could modify it here. and say, let's say D4 for example. I'm going to change this back because that is not the MAC address. But I do that, and it imports it. By the way, that part where it says new revision 1.2, revision 1. Previous revision is 1.1. That is because we check every one of the imports of the spreadsheet into RCS, so that we actually have a history. I know RCS is old, but we needed a directory specific repository. Using Git was overkill, so we decided not to go with Git on that. So that's why we use RCS. I cannot imagine a single machine that actually does not come with RCS already built in. So that was an easy solution. But the good thing is, actually this is great. Now check this out.
So this is the truth part.
Yes, this is the truth part. This is the one where the spreadsheet literally is the truth of the machine itself.
Right.
There is no translation. There's no guy looking at the spreadsheet and typing commands in.
Right.
That's basically what that means. Now, obviously, I know that is wrong, right? So I can go back to so what I do is I go to export stack spreadsheets, and I do checkout Stacki demo -r1.1. Yes. I've actually forgotten how to do this.
Where's your restroom here?
There we go.
Into the hall and there's one in the kitchen. Just go in there.
Now, if you look at that,
The one you'll
Go in
find.
the direction.
you will see that it actually has the correct old IP address, the old MAC address in it. So now I want to put that back in place. So let's just make sure I have the wrong one in place. So this one says D4, which is incorrect. I do stack load host file equals stack demo, and puts it back in place and creates a new version for it. So we're basically set. So stack list host interface now has everything correct. Yes, go ahead.
If you were gonna, because you were changing it, you were changing the database from here.
Okay.
If you had made the mistake, you wanted to make sure you changed it on the spreadsheet.
I actually
Did you
no,
not
I
change
changed.
it on the spreadsheet.
Actually, I changed it on the spreadsheet. I just did it here. That's all. It was the CSV. So the
Oh, okay.
one I modified was actually the CSV file.
He's saying the input file.
This is the input file. So if I were to put this out there, this is actually the same as the spreadsheet. This is the spreadsheet. It just looks like this on the command line versus.
Right, but I think you had imported.
I had imported an incorrect spreadsheet, and then I changed the spreadsheet, and then I imported again.
Oh, I see.
That's what we just did.
So my next question may not be
Yeah.
applicable, but I'm going to talk about an enclosure
Mm-hmm.
with virtual NICs, which I have MAC addresses, which, I use vendor
Right.
to configure,
Right.
right? Let's say I goof up
Mm-hmm.
somewhere in there, or I just decide to change my mind. This is still going to behave the same way it always has.
This is pretty much, yeah. This is going to behave exactly like this, yeah. So, I mean, it has to match the hardware. Like, if you were to run ifconfig on that machine, like, let's say Stacki doesn't enter the picture here at all. You just use whatever other tool, Red Hat, CentOS, whatever. You do the installation, and it comes up. You do ifconfig. Whatever the MAC address is there that shows.
There's always that separation, is my point. There's always that separation.
Right.
It's going to be physical to.
Oh, I see what you're asking. Okay. Yeah, I mean, we would take the MAC address that would normally be reported by the kernel.
Whatever's being reported.
Exactly, whatever is being reported by the kernel. And as I mentioned earlier, because we are Red Hat based, we actually use the installer and the installer kernel itself to kind of make all these decisions. And there's also another aspect to this, because this controls installation. I'll show you how it does it. So what happens is when you boot up a machine, it's going to DHCP out, right? It's going to PXE out.
Right.
And when it does, it actually uses a certain MAC address that has to map to this.
Right.
So I think, we're basically on the same page in that case, yeah.
Okay.
Yeah, so it behaves exactly like
So
that.
we know that traffic is going to be captured somewhere, and you're looking for it.
Exactly.
It's broadcast.
Exactly.
Okay.
Yeah,
Alright.
exactly right. That is basically what happens. Okay, so now we've actually used a spreadsheet method. Oh, oops, I don't know what happens. Alright, so we've used the spreadsheet method to basically import my host into the cluster. So I am going to now, I'm going to give you a little bit more detail here. So I do something called stack list host boot. What this is saying is that the next time I run, I want those machines to go into OS mode. By the way, this is the default that we always use when we import from a spreadsheet. And the reason is, we've had lots of people who said, I imported my machine, I turned it on, and it reinstalled. And the question we asked was, what did you expect? Isn't that what you wanted? Clearly not. Clearly that was something that they didn't want.
So you skip that baseline altogether.
So what we do is actually say, don't be destructive. Basically, when you ask for the Pixie file, simply say boot from yourself now. Because we don't want to touch it until you as the administrator forces an installation. So at this point, I'll force an install. I'll say stack set host boot backend action equals install. So this actually shows another feature of the command line itself. So you see the host names, backend 00 and backend 01 are appliance types backend. So when we actually do, when we type out the command line, you can specify backend, you can specify the appliance type as opposed to individual host names. So you have like this catch-all thing that you can use to kind of control a set of hosts as opposed to one host at a time. So you do that, check again.
It could be lethal.
Sorry?
It could be lethal.
Yeah, that could be very lethal, yes. What's good is, this doesn't actually do anything. Like all this says is the next time you reboot, do something. So if you catch yourself in the middle and you say, oh God, I didn't want to do it, just put everything back in OS mode and then reboot your machine.
So is there a way to just show us what's in the queue ready?
What's in the queue?
Like we know on a reboot it's going to install.
Yeah.
So is there a way to just
To determine what action you're at.
what actions are pending?
Pending.
This is actually a stateless system in that sense. There is no state, so there is no pending action.
Okay.
Yeah, this is not something that happens on top of another action. This is basically the next action, or that's
So the
it.
front end is not recording the queued jobs.
Then no, it is not recording the queue jobs. It's maintaining current state in a sense. Yeah, that's it. And there's no, oh, do this first and then do the OS and then do the install.
So
there is no.
Let's say I recognize right after hitting enter
Mm-hmm.
or command
Mm-hmm.
that I made a mistake. I want to undo.
Okay.
I can remove that pending.
Yeah, you can actually go back here and say action equals OS,
Okay.
and then it puts it back in the same
Alright.
state as before.
All right.
That's basically it. So I want to install in this case. Oh, actually, you know what? Let's do that. Let's do action equals OS. So I'm going to turn on one of my backend nodes. You guys can see the thing, right? Yeah. If DHCP is out, gets a config file, but the config file it gets is boot from yourself. So all this is doing is booting from itself. Now for the other guy, this is backend 00. So for the other guy, I'm going to say backend 01 action equals install. Only for the other guy. So we can go back and check here again. Backend 00 is still OS, backend 01 is install.
So I guess that would be the command that you were looking for.
Right.
If you go just host boot,
Yeah.
Yeah.
it gives you what action.
Yeah.
What
it's
action
at.
was
List host boot
that?
is what gives you the actions, yes. So now let's do backend 01. DHCP is out, but gets a different file. Gets a different Pixie config, goes in install mode. We'll just let this go in install because I don't need to worry about what's going on in the back. But if you'd like, I can walk you through what's happening. But it's a very simple installation, and if you go through it, you will see that it looks exactly like a very standard Red Hat installation. So I'm doing the Anaconda. In fact, we actually hook into Anaconda to make sure that it and sort of piggyback on top of that. It gets the kickstart file, gets the install images, and then basically starts the installation. One thing you need to know is we don't do ghost images. We don't do golden images at all. And the reason is golden images are extremely hard to control. So what I mean by that is, if you have a golden image that somebody else has done,
Right.
and they say, oh, boot from this, and then modify it by hand, you're now starting to, it's okay to do that for one machine, one image, and then the second one you're already struggling.
Yeah.
And the third and the fourth and the 10th. By the time you're up to the 10th, you're basically trying to beat yourself over the head with the keyboard.
Right.
So it's going to get that bad very quickly. So what we do instead is we manage configuration. So I'll walk you through some of the configuration parts in a bit, but the analog that we typically give people is you can modify the source code and compile it into a binary, or you can take the binary and try to modify the bits in it. That is the actual difference between modifying using Stacki versus using a golden image based system. That's the difference that we typically that's how we describe the difference. Okay, so this one's done. This one's getting done. Actually, this is also going to show an interesting thing when it finishes. This should take, again, this is a VirtualBox machine, so it'll take typically 395 packages. Takes about 2 to 3 minutes to install. So you have a full-fledged system up and running in about 2 or 3 minutes on a 10 gig network and things like that. Another important part I wanted to talk about is the installer itself. Actually, I have a couple of slides on that.
Is there a limit to how many hosts you can target?
At the same time,
Yeah, I mean bandwidth not being a factor.
I will actually tell you that in a second. The short answer is no, but the long answer is it depends, basically. So, and I'll actually tell you why that is. So let's just kind of go through this quickly so that we can cover a few of the things that we just talked about. Basically, as I said, you have this host configuration spreadsheet, save it as a CSV, use the StackIQ command line to load it onto the front end. Tell all the backend nodes that the next time they pixie boot, they need to go in install mode. I just showed you how to do that. And then you pixie boot all the nodes. They basically send out the request and then get the image back, and you're done. This is going to answer your question. So what we have is, and this was designed a long time ago, what we have is a BitTorrent-like installation system, peer-to-peer package sharing system. So if you have 10 hosts installing at the same time, they're all going to be sharing packages from each other. So the front end's load is actually pretty low. You still have to go, so everybody has to go to the front end for at least a small set of packages. But once each of them actually has a set, it basically starts to install, starts to package share. And if there are some machines that are a little faster, or some that are slower, they're going to exit out of this BitTorrent pool, just like your standard BitTorrent installation, downloads itself. So as new nodes join in or old nodes leave, the nodes that are actually trying to get packages from other nodes, if they fail, they go back to the front end. So the front end's always going to have the packages. But the backends will have the packages only during the install phase. So once they're done installing, they no longer are able to serve out packages. So they actually exit out and reboot. Whereas, so all the other nodes that are actually doing it, so they will talk to each other, try to get the packages, and if it's not available, go back to the front end. So if you have 100 nodes installing at the same time, you actually have a really, really fast installer at that point, because they're all sharing packages between themselves. So it scales very, very easily. So theoretically, no, there isn't a limit.
So theoretically,
yeah. So our limit, you could scale
install,
it up. Yeah. We've actually installed. I think the last reasonable test we did, which was limited by the number of nodes that were there, was 300 nodes in 14 minutes.
Is this on a real physical network?
Yes.
Or
No, it's a physical 10
and you
gig.
opened up all the pipes.
It was a standard 10 gig Ethernet net. That's
Really?
it. Yeah, that's it. 288 nodes in 14 minutes.
Is this behavior? Can you control it?
You can control it to up to a point. Meaning, I don't know if you. It'll basically occupy the whole pipe as it's doing the installation, as much as it's allowed.
Right.
You can control it. There is. You can do rack affinity with the installer, so you can actually say. Prefer your rack before you go to another rack for installation. Right. So when you have subnetted racks, you actually go through your rack first and try to get everything from your rack before you go to another rack. And then if you can't get it from anywhere, then you go to the front end again. So yes, you can control it up to a certain point.
Can you interrupt?
If you
Let's say you got crazy,
Mhm.
went for 1,000 systems,
Mhm.
and then
Little July.
oh, I forgot this was going to take that long, and now it's past my maintenance window time.
Okay.
And I want to, okay, we'll try this again tomorrow.
Right.
But I don't want to start from scratch.
Actually, so what we have, what we typically do is the way we've designed the system is, it allows you, in fact, it doesn't require you, of course, but it makes it so easy to start from scratch that it basically that stops being a burden. That stops
Okay.
being
Okay,
the
that's-
hindering factor.
Right.
So
You might as well start over.
you might as well start over.
Because
But
the
again, when you
payoff
say
is-
start
is-
over, it's
yeah.
not a start over as in you start all your systems over.
Right.
You start only the ones that you couldn't finish.
Right.
That's it.
Okay.
That's basically it. So if you start, let's say,
Okay,
1,000
that makes sense.
machines.
I get it.
Yeah.
I get it. Makes more sense.
Okay. So you can definitely control it
Each
in
one
that
reports
sense.
the status it's in.
Sorry?
Each one will report back the status and they're all independent.
They're all completely independent machines. Yes. And again, if for some reason you hit a point where you said,
They're
"I'm out of my way,"
They're working in parallel, but many will finish prior to others.
Exactly. And
So-
at that point, what happens
Right.
is the ones that haven't will go back to the front
So
end.
there's no like queuing
There is no queuing as
and,
such. Yeah.
and ticketing per se.
No. There isn't. It's all completely. It is
Wow.
stateless in that sense. Yeah.
Okay.
Yeah. In fact, I could do 2 machines on my really kind of crappy old VirtualBox cluster in about 15 minutes, which is honestly really fast.
Yeah, that's. I get it. And I hope I'm not derailing the conversation. with my-
No. This is actually no. Again, like I said, this is for you guys. So any questions you have, feel free to ask me. So don't hesitate. So let's go back to the PowerPoint and let's see what else is there. So how do you customize your hosts, right? So now we've done all the standard stuff. We've basically got the standard installation mode. You've got automatic partition, automatic partitioning. We've got automatic name assignments in many cases. You don't have to, obviously. If you go through the spreadsheet method, you basically specify the names, IP addresses, all those things. How do you customize each of these things? We have a saying around the office. When you design a really good hammer, every problem looks like a nail. So that's what we did. We said, if we can do spreadsheets for one thing, why not use it for everything? So we can use the spreadsheet configuration method to do bonded interfaces, VLANs, bridging, combinations of any of those things. All sorts of, you can go crazy. You can manage hosts in multiple subnets. So this is a feature that actually is so strange that most people didn't know that you couldn't, because nobody expected to use an automated system to do this. What I mean by that is, you'd have multiple subnets and people would say DHCP isn't working over these 2 subnets. And DHCP was not really meant to work over multiple subnets like that for the longest time. That was not in the original spec. But people put in relays, right? People put in helpers. They said, oh, we have this new thing called helpers. Okay, this is the first we've heard of that. But we started seeing it in multiple places. We said, okay, we have to figure this out. So we have to somehow manage to get multiple networks. We have to be able to serve Pixie images, DHCP images over multiple networks if you've got your DHCP relays set up correctly. So we did that. So now we can even specify separate networks and say install over multiple networks. This kind of gives you the ability to manage hosts in multiple data centers. So a lot of clients, what they typically do is they'll segregate a cluster into the production and the DR clusters, the disaster recovery clusters, and then they'll say we'll put these in 2 separate 2 separate data centers, but they'll still share some kind of a network space. So we can actually do that as well. So as long as you've got the physical pipes connected correctly, you can actually do that as well. This is another example of the host configuration spreadsheet, and this is the one that we actually use at work. So every node is configured in every node has a host name. What we mean when we say boss is that's the name of the front end that it's connected to. So if you notice, this one says node 203. right here, and node 203 isn't there here. Okay, let's do this. Node 215 is the front end. And is there any other front end here, any back end that's connected? I guess this is a snippet of the spreadsheet, so a lot of things have actually gotten moved around. But what we do with this is our global office spreadsheet. So everybody downloads this spreadsheet from Google Docs and just imports it into their cluster. Because what happens is the front end knows what its name is, so it looks for that middle column that says boss and says, oh, these are the hosts that belong to me, and those are the only ones I will import into my system. And the reason we did this way is so that we could actually pass nodes back and forth between different members of the engineering team. So this can actually give rise to a lot of abuse, as you can imagine. Halfway through somebody's testing, somebody else just takes over their node because they put it in the spreadsheet, imported into themselves, and the other guy lost it. So we use this as a we still have to have external coordination when we go through this, meaning, hey, don't touch my nodes. We still have to do those things. That's a very, very human-centric problem. I don't think we can do that. Yeah.
Nightsticks.
Yeah. Yeah, we have what we call a clue bat at work. It's a very small baseball bat that we can hit somebody over the head with if they get out of line.
I have a user education tool and an admin education tool sitting on my desk. The user education tool is a small jeweler's ball peen hammer. The admin education tool is a 3-pound sledge.
Smart. Very smart. Alright, so as I mentioned earlier, if you have a good enough hammer, every problem looks like a nail, which is our philosophy. So we decided to take the spreadsheet approach to doing disk controllers as well. Now again, if you've configured LSI mega rate controllers or you've configured HP controllers, you will start to see similarities in it. You have slots where each of the physical drives sit, you have the enclosures, you have the RAID levels you want for these things. The array ID is something that is not quite the same, but what the array ID means is that is the order in which you actually provision these disks. So if you take the one on the left, it says global slot 0 and 1 are raided together in the RAID 1, and that's array ID 1. What that basically means is that is going to map to STA because that's the first one that got created. And the second one is going to be for backends. It is and the global one also says *0*. What that basically means is all the other disks in your cluster make them RAID 0, so almost like a JBOD. And then order them as you want because you don't really care. For backend nodes, the ordering is 0 and 1 basically are raided, are RAID 1s. That's the first one that comes up, so that will typically be your OS disk. And then everything else is 2, 3, and 4 are basically a RAID 5 setup, and that's the second one that comes about. This is a hot spare that belongs to this array, which basically means that this has disk 5 has hot spare affinity, which means if you lose a disk in that array, it goes into that array only. And on the right side is a slightly more complicated spreadsheet, and that is a node-specific spreadsheet. That's a node-specific spreadsheet. And that one, again, has all these complicated things in it, which is, if you look at array ID 1, it's this and this. So disk 15 and disk 5 are rated as 1. Don't ask about the setup. This was, these are crazy setups. We've actually got clients who ask for things like this, and the reason they ask for it is, disk 5 and disk 15 are SSDs, so we want to make them OS disks. So we're like, okay, fine. If that's what you want, that's what you want. So we put that, we put that feature in. Create that as your first array, and then everything else. Array ID 2 is the first 5 disks. Array ID 2, they're all rated 5. And array ID 3 is going to be down here, again RAID 5, array ID 4, RAID 6. Here's another interesting thing. It says hot spare for array ID 4, which means those two hot spares belong exclusively to that array. And then you have 2 global hot spares, so any disk in the array fails, these hot spares can actually take them over. Same thing for partitioning. we basically can define partitions using spreadsheets again. But again, all these basically are talking about the backend nodes. So the global spreadsheet simply says apply this to all machines. The node spreadsheet says apply this to that particular node. The node one always overrides the global one. So you can have a global spreadsheet applied to everybody except node 221. And again, you have different partitioning schemes for each of these. This one does not talk about LVM, but with the latest release of the software, we actually support LVM partitioning using spreadsheets as well. Finally, we come down to multiple distribution. This sort of goes back to the question that you asked earlier about how do we add, we have a stripped down version of CentOS on the system. How do we add more things to it? And this is how you basically do it. Once your front end is up and running, you add the CentOS 6.7 ISO to it as a palette, and you basically install the whole system. You can update the system to bring it to that. And you use that to build backend nodes. So you can actually do it in such a way that you can say this set of backend nodes are going to be Red Hat systems, and this set of backend nodes are going to be a CentOS system. And you can have combinations, which is some with service packs, some without service packs. You can have prod clusters and dev clusters. You can kind of segregate all of these, all of your machines into different buckets and boxes. And yeah, so you basically assign it to any backend node to any kind of distribution. So try it out. If you need, so you can download the software at Stacki.com. You can get the source for Stacki. As I said, it's open source. It's available on GitHub, so you can go to the GitHub page for Stacki, look at the source code, look at the documentation for the source code. You can join the Google groups, which we highly recommend. It's pretty engaged right now, so we can answer any questions you've got. You can join the San Diego meetup one, but the thing is, you're not going to be traveling to San Diego just for the meetup. But the reason I say that is we actually put all of our online meetups on there. So tomorrow, we actually have a meetup on how to install CoreOS. So how many people here know what CoreOS is? Okay, you know what CoreOS is. So have you guys heard of Docker? Mm-hmm. So CoreOS is basically like Docker adjacent, I would say. It's a way to run Docker-like containers. So it's a very stripped down OS, and you install it in your data center instead of going out to the Docker data center to run your Docker apps. And then you use CoreOS to run all your Docker container apps on your local cluster, for example. So tomorrow, my colleague is actually talking about how to install a CoreOS cluster. So if you have 100 machines, you basically can install CoreOS on all these guys, and he's going to talk about how to do this. And we have a Stacki Fest. So on March 24th, if anybody would like to travel to the Bay Area in March 24th in Milpitas, we actually have a Stacki Fest. It's a one-day event. It's free, so anybody can drop in and sign up and drop in. And yeah, if you guys are interested, you can join in. I have a whole bunch of more slides, but I thought we can go back to the demo, and if you guys want to know more, happy to answer questions or cover a few more slides if you want. But I'll just jump over a little bit to the demo. When we left the demo last, we were installing backend 0.1. We'll see if that's actually finished. This is backend 1, so that's complete. So you do, it's up and running. So you do uptime, it says it's been up for 14 minutes. Now here, this is where the interesting thing happens. If I do that, you will see that the action has been reset to OS. And this is exactly what you want. You set the machine to install. When it's finished installing, reset it back to OS. So one of the last things that the machine does as it's going through its install is sends a note back to the front end and says, I am done. Make sure that I don't go back into install mode until an admin says so.
Captured its last state.
It just becomes it actually doesn't even capture it. It simply says, I'm installing, I'm finished, reset me. That's it. That's all it does. So it resets back. So that's why when the node reboots and Pixie boots back, it can boot back into its original OS state.
So if something happened in the middle,
Yeah, it doesn't
there's
reset.
a power glitch.
Yeah, it does not reset it, and that's exactly what you want.
Okay.
Because when something happens in the middle during install, you want to go through a reinstall. You don't want to start off
Right.
where it's
Right.
I don't want to figure out where.
Yeah.
Right.
One thing, the other thing we've realized, and this is another thing we've known for a very long time, is do not try to debug problems. It's usually a good idea to just take the brute force approach and do it.
Go away.
If it happens repeatedly, it makes sense to actually do and if it happens over multiple machines, then there is a systemic problem. Yes, you should debug, but one-off errors, just just ignore it. So this is basically a reset of that. So now I can actually connect to each of these backend nodes. I can connect to each of those backend nodes as I mentioned. Here's the interesting part. Part of the command line itself, as I mentioned, has a parallel execution shell. So I can do stack run host backend command equals hostname. It connects to each of these backend nodes and brings back the response. How many people here use Ansible? Anybody? Puppet, Chef? They all have parallel shells, but we like ours the most. This one's fast. Yeah, it's simple, but it's super fast. It's just simply shells out, connects to the machine over SSH, captures response back and comes back. What else? Yeah, so that's kind of it actually. If you guys have any questions, we can go more into details about why is this a hard problem to solve and how we actually kind of go about it, or we could break for questions. Anything you guys want.
I had a question.
Sure.
Are there plans to look at other distros other than the Red Hat line?
Yes, Ubuntu is on our roadmap.
Okay.
Ubuntu is definitely on our roadmap. In the past, we've actually installed, as I mentioned earlier, there's a CoreOS demo tomorrow. I'd be happy to send you the link if you guys wanna, if you guys join the Google groups, there's usually a message that's sent out. So let me go back to that if you guys want, if you need a link. There's a message that's sent out that kind of tells people that there's a demo going on or something like that, so you can actually join in. It's a simple WebEx demo, so connect to it and watch my colleague actually give a presentation. But in the same spirit of doing CoreOS, we are thinking about looking at Ubuntu. We've done VMware in the past. We've actually, in the Rocks days, where the university days, we've even done Solaris. So that's how far back the system design actually goes. So yes, Ubuntu is definitely on our roadmap.
What about SUSE?
SUSE is also on our roadmap. Yeah. In fact, we've actually taken. So again, like I said, we have depended so heavily, on the Red Hat installer, which is why we have been so Red Hat specific until now. But once we kind of went into the Stacki mode, we realized that there are lots of these other automated tools that we can use for each of these things. So SUSE, Ubuntu, they're all on our roadmap. There have been some exploratory development on it, but nothing concrete has come out of it. Yeah. Any other questions? Okay. Is there any specific demo thing that you guys want to check out? Do you want to see something specific in the demo?
So you said you can double tap, enter.
Oh, the command line itself? Yeah.
Yeah. Is that for all pieces of the command, or is that only for a semi-formed command?
I knew somebody would ask me that question. Well, let me put it this way. I wrote this piece of code about 4 years ago, so I don't know. So I can do that. I do add, it completes. So there is tab completion. It's basically standard Linux tab completion, but here I can also do that. So I could do add host nothing, add host attribute, add host bonded. Oh, another important thing I wanted to talk about was attributes. When we talk so much, we've talked about how we do a lot of this control, and a significant part of that is actually using attributes. Now, if you've used Windows in your environment, you are well aware of the Windows registry. So we've actually taken that idea, which is a really powerful idea, and we've kind of converted that into the Stacki database. So what I can do is I can say list host attr backend 00 and it gives me all the attributes that are part of that system. This particular attribute, nuke disks equals true, basically is an attribute that controls how you do your partitioning. So if nuke disks is set to true, it wipes away all your disks, all your partitions, and reinstalls on top of it. If you set it to false, it only wipes away /var and actually those might be the only two ones it wipes away, or /var and temp or something like that. So we are very surgical in how we do it. So your data stays safe, through a reinstallation as well. If you do nuke disk equals false. There are a bunch of other attributes. There are something so the last column here that says IG. Actually, this is kind of a bad way of looking at it. Let's do this. List host after backends. Yeah. I guess it just keeps going there. But basically, this is actually the last column in that list, but because it's spaced differently, it comes out from the side. But what that's actually saying is there are some internal attributes, and then there are some global attributes, host-specific attributes, and appliance attributes. Now, what that means is intrinsic attributes or internal attributes are inferred. They're inferred attributes. So you would have provided networking information, you would have provided IP address, host name information. All those are present in different parts of the system, and they're all inferred. So you can't actually change those attributes without actually changing the characteristic of the host itself. Whereas the other ones, the ones that say G or A, they refer to global attributes, appliance attributes. Those are the ones that are talking about how how you want the system itself configured. Meaning, do you want the system wiped clean when you do a reinstallation? Do you want it to belong to a different type of appliance? Things like that. So these are attributes are basically entities that sort of control how a system's installed and how it is configured and what its behavior will be. So yeah, this is another sort of important piece of the puzzle. Okay. Any other questions? Good. Again,
You mentioned LSI specifically and HP a few times. Do you work with Dell's rebranded?
Yes.
Okay.
If it answers to store CLI or mega CLI, which I know Dell does, we can do it. In fact, that's where we kind of got our start with Dell gear. So
Okay.
Dell.
I thought I saw a 720 XD in your bigger spreadsheet there.
Yeah, it's very yeah. That's true. That is true. Yeah, it was actually part of that. There we go. Yep, 720 XT right there. Yeah, in fact, we at work we have basically Dells and HP, so that's how we configure. that's why those are the two ones we can support easily. And I don't really know of any other server grade controller as such. I know Adaptec makes not Adaptec. Yeah, Adaptec. I think. Yeah, but yeah, exactly. They used to be around, and that's mostly now like very low key hardware, I think. So yeah, these are the only two that I know of that pretty much all vendors use and support. HP obviously is only HP, but right. Cisco, Dell, IBM, they all do the LSI controllers. Okay. Any other questions? No? I guess we're done then.